Hello everybody. So, so today I'm gonna. I'm Pierre Souchet. So I'm working for Criteo and I'm leading a team responsible for the discovery of services within the company. I'm also working a lot on Consul, improving it with performance and security patches. And I also wrote a few tools around Consul, Consul Template RB, and HA Proxy Consul Connect. We will see it a bit later. So today I like to. So here is the menu. We'll start a bit with seeing how Criteo started doing service mesh and why we did it. Then we will see how we use Consul Connect for now and how we plan to use it in the future and what we did to make it work. So Criteo is a company displaying ads on the internet. So it's a very, very large infrastructure, around 40,000 servers with several data centers, with many kind of services. We've got around 4,000 kind of different services and many, many instances, around 250,000 different instances of those services. And we are being hit all the day by many, many requests per second. And we'll see that it's very, very important for the business to be both very fast and being able to handle a large number of requests per second. So what I propose is I'm gonna come back a bit in time in 2010. At that time, Criteo was displaying banners with monolith applications. At that time, it was already huge. We had already lots of servers, and we were. What is critical for Criteo is having a very, very small latency. We are participating to auctions on the internet to know who is going to display an ad. So it's really, really important to be able to handle large volume of requests with very, very small latency. So at that time, we reached a point where our big monolith application were not able to evolve anymore. The data set of the data handled by this application was too huge for a single machine. The code was too large. It was too slow to upgrade, and we had several of those applications sharing the same information. So at that time, we wanted to move towards microservices. So it's not microservices like a very small feature or something like that. It was a huge feature, but just huge applications doing just one thing, such as guessing whether we should display the banner for the user or not, for instance. So we started doing microservices. And as I told you, we are supposed to answer to those requests very, very fast. So it was directly in the design a major request to be able to be very, very, very fast. So we had two solutions to address those services. Either we should go so our application was supposed to call other microservices, and we got, at that time, we had two kind of ways doing it. Either by choosing a kind of load balancer architecture. So basically, the application is gonna call a load balancer, and the load balancer will forward the call to the service itself, or do service mesh. So service mesh is simply your application is contacting directly the microservices it is interacting with. So we had those two opportunities. And just to give you some insight about what kind of load we have to handle. This is a real graph of the bandwidth on one server of one of those microservices. As you can see, it handles more than 2 gigabytes of data on the interface. So it's actually several instances. So it's very, it needs lots of bandwidth just to compute the data. And the east-west traffic within our data center must handle those cases. So we had 2 things. We had a huge bandwidth between those microservices, a really important business need for very low latency. And at that time, the architect of the within the company computed that we would need around 100 load balancer per data center. And at that time, we had 6 data centers. So it was a huge amount of money just to be able to route those calls between our application and the various microservices. So definitely, we at that time in 2010, we chose to go to service mesh. So in order to do that, what we did was simply building small APIs embedded into our applications. We call it CSSB for client-side load balancing. And this API is targeting the various microservices needed by the application. So it's very interesting for us because we have minimum latency. We have the bandwidth which is shared by host, meaning that you don't pay twice the cost of the east-west bandwidth within your data center. You don't need additional machines, for instance. And we choose to simply use a database to update the various targets, because as soon as you start having lots of microservices, of course, you have to get a kind of repository of where to reach a microservice. And this library was implemented at that time for both C# and JVM, which were the major targets in which our applications were written with. So everything went well, and we used this mechanism for quite a long time. It was not a big deal because we were using almost only bare metal servers. So the servers were installed, they were registered, they were running just one kind of microservice or application, and they were running all the time like this. So in the API, we were detecting the failure of the node and so on, but everything was working quite well. The only drawback is in 2015, we wanted to introduce containers. So why do we wanted to introduce container? The first very important thing is it avoids having one machine per feature. The big drawback of installing a complex application on a single machine is it kind of taints the machine, meaning that this machine is not usable for another application later. So using containers would allow us to have just one kind of hardware and just starting a container on this machine, and then, for instance, during the night, fewer people see ads, so we can reuse this machine, for instance, during the night. So it's all about money. It's being able to share CPU and memory and to share machines, so to have less machine in the end. The other interesting stuff was scalability. At that time, just to create a new machine, we spent something like a few hours to install the machine, to install the software on it, to register it in the database, and so on and so on. And of course, the final issue we want to tackle with container was reproducibility. Those instances were running for quite a long time, and the operating system was aging. So people sometimes did connect on the machine was working less well, and so on. And containers offers a way to have clean machine always, and not to have some kind of weird side effect because something has been installed on the machine, for instance. So as we know, everybody know this this kind of stuff. So those are the pro for containers or virtual machines, but there are also some drawback. The first drawback is as soon as you start having containers, your database is not enough to keep track of all the changes in your infrastructure. Furthermore, we had at that time already lots of machines, something like, I don't know, 20,000 of machines talking to other machines. And the database we used to feed the API, the client-side load balancing API, was showing its limit. Lots of requests per second all the time. It was also very hard to update this value. And the final point is all those instances CSSB API had no idea of the health of a service, meaning that all those applications needed to periodically query their targets to know whether those targets were still healthy. Because of course, when you've got thousands of machines, there are always some machines that are down or unreachable or whatever. The other point was due to low latency and simply legacy, we could not afford to use software-defined network or something like similar. We had to just use bare metal machine, and we could not afford to use virtualization of network. It means that we had to run several containers on the same machine on different ports. And most of the database was not ready for that. It was only one single port for one service. So that was another big issue we had. And of course, having containers means that you can have better granularity, meaning that your instance can be smaller. Being smaller means that you can gradually adjust better your workload instead of having large monolith, large applications running on a single machine. So it means also that you got far more instances with containers than with bare metal machine when you have just one single application. But of course, all of this make it very hard to discover where your services are. So this move to containers was really showing the limits of all of what we made before, and we needed something new. So at that time, we chose to use a Consul, so around 2015. Why? Mostly because he had kind of reasonable service abstractions. It was independent of the network. We are running several ways of running applications. We are running bare metal, of course, Hadoop, Mesos at that time, Kubernetes, cloud. So we are running, and of course, so we had many ways of starting those applications, and Consul offered us a way to describe where those services were, so our service mesh could still work. It also offered a live update of all those changes, including health information. As I told you, it was really hard because the CSSB has to query all the targets. In some of our pools, we've got, for instance, 2,000 instances of a given service, meaning that each of the application targeting this microservice has to just to probe which target it should reach. It's gonna perform 1,000 health check just to get this information. So it's very not efficient, especially when you have more and more of those applications. You're spending just your time probing whether the targets are healthy or not. And finally, Consul was built in with fault tolerance as well as multi-DC, and we were in that case. So it was it was a good choice for the requirements we had at the time. So basically, we plugged Consul everywhere. It's now a full backbone of our company. It's very important. When Consul is done, nothing works. So all this information is now, we've got around 4,000 kind of services. so with more than 200,000 instances. And everything is updated all the time and in all of our data centers. So what we did was we now use Consul to have a unified view of what's within our data centers. So every machine is registered in Consul. Every service, whenever it is running on Kubernetes, on Mesos, on Hadoop, on or just a bare metal service, everything is in Consul. It was very interesting for us because our first big goal was to have a service mesh and to be able as well to use classical edge load balancers. So Consul is not only used for the service mesh, it is also used to automatically provision overhaul load balancer. So basically, when you are performing a request from the outside of Criteo, you are reaching a load balancer, and this load balancer is provisioned automatically with Consul. It gives us a very strong edge compared to what was previously. Before that, in order to get a new service on the internet, you could spend something like, you had to create several tickets to the network team and so on, and we could spend up to 3 weeks just to get this service up and running. And with Consul, everything is automatically declared and everything is automatically provisioned. It was a very hard way because it was a very hard path to follow because we found several optimization due to the large number of instances we have. But now we've got a full database of everything, and it's provisioning all the communication between all the systems. So what's next? So we are now quite happy with, so we started the move to Consul in 2015. Something like 2 years ago, we had load balancing provisioning. We had all this service mesh relying not on the old database, but on Consul itself. So what could we do better? So the first thing to understand is writing your own service mesh is quite hard. We have to support libraries in 2 languages for the JVM, so Java, Scala, and so on, as well as C#. We have to be consistent, so it's a lot of work just to get the metrics being consistent, to have a kind of similar behavior. It's around 10 kilo lines of code just to get that, and very sensitive code. Those client-side load balancing APIs usually deal with pools with 2,000 instances, for instance, with many clients and so on. And just a few changes in those library might degrade, for instance, quite a lot the performance and so on. So we are, when you are changing something in this code, it's very hard, and you have to be very careful. For those programming, you might know that whenever everybody is using HTTP, it's very hard to get it right. Just if you use Golang, for instance, you can set timeout on the HTTP level, ideal level, on the socket level, on the operating system, and so on and so on. Everything is very complicated. And if you want to have something very reliable and with very high performance, it's a huge work, and you're spending quite of time optimizing it. The other point is, while in 2010, everybody found completely normal that nothing is encrypted in the data center, it's not the case anymore. More and more of the traffic on the internet is using TLS, so HTTPS, but people want TLS even within the data center. And whenever you've already programmed TLS validation, and if you have to get it really secure, it's very hard to program as well. And it's the kind of feature we cannot afford to add in those SDK very easily. So that's a big burden. The other point is HTTP2 is coming. on HTTP 3 as well. So implementing all of this is a huge pain, and it's really hard to get it right. And the other point is we are using this service mesh, and we develop lots of SDK for our application, but whenever we want to use another application for which we don't have the source, for instance, we cannot plug it on the system. We have to use classical load balancer. So that would be interesting if we could use a kind of abstraction in order to replace this service mesh, still have the same performance, and not being forced to modify every applications to run with this model. So what about Rust, Go, Python, and so on? So that was a lot of open questions. So Consul Connect does exactly that. It can work with or without software-defined network. It can work with a sidecar or not. It has a good feature set. It's not too bloated. There's not too many features. It's sidecar agnostic. Intentions allow you with kind of SEL to protect your services from being reached by other systems. And for us, we are working with Consul for quite a long time. We know where the code base, so it was a good candidate. The big downside of that was the sidecar was not working with Windows, and we've got lots of Windows machines still. It also adds some latency, which is exactly what we try to avoid. And it Envoy requires recent glibc, which was an issue for us. So what do we want to do now is simply adding TLS everywhere. So adding HTTPS within our data center. So it's very basic. And while it is basic, we decided not to use Envoy, mostly because Envoy was not supported on the majority of our machines. So, and we wanted to get more confidence with what could Consul Connect provide us. So we decided to implement our own. So it's a kind of weird, I agree. But we had lots of expertise regarding HAProxy. HAProxy is a very old load balancer. And we wanted to run it on our old Linux distribution. And so we started as a project to re-implement Consul Connect with HAProxy. So the project is called HAProxy Consul Connect. It's an open source project. So you can test it. It works with all glibc, of course. It's a subset of Envoy, so meaning that all the features of Consul Connect are not implemented on mostly for now HTTP, but it's simpler. And it is also tested in our large infrastructure. It is developed basically by Criteo, but maintained by HAProxy Tech, the company behind HAProxy. It sends logs on Prometheus metrics, and it's very easy to hack because it's a subset of Consul Connect, basically. Still being completely compatible, of course. So it's simpler. It offers a bit some better performance. I don't have graph, unfortunately, and it's easier to debug than a full Envoy. So less features, and being stable on not having too many features was very important for us, because out of scale, it could advanced feature might cause issues. So what did we have to do to make it work? The first was the standardization of all the features of Connect we wanted to use. To avoid using too exotic settings, you also want to have links to the various metrics of Connect, of your proxies. You want logs, you want dogs, management intentions. So there is a few screenshots of our dashboard of Consul that show a link to Connect metrics, if you see it on this slide. And whenever you are clicking on this, you go to our Grafana graph for the correct service in the correct data center. And here you can see the outgoing traffic of the application. So this is an application. You are seeing the outgoing request per second, and you are also seeing what are the target of this service, meaning that this Connect enabled service we'll target a service called Prometheus Discovery Graphite Remote Adapter. And you see the specific details of this service, meaning that for all of the outgoing traffic of this service, you can see which service is targeted, how many requests, how many HTTP 200, and so on and so on. So we made lots of standardization with that, and you can have a clear overview of what is going on within your service mesh. You've got the same on the other side, on the service being targeted. And of course, we had also to implement collecting logs for all those new proxies, send those logs to Kibana and so on. And our current status is we are using it on a few services, just a few dozens, but for months and for critical services, meaning that we are sure that this system is working well in our case. It is working on a few services for now, because what is very hard in those systems is when you have to deal with a large number of instances. So it's around 2,000 queries per second on the largest Consul Connect services, and throughputing around 10 megabits per second of data. So what's next? What we want to do next is deploy the same exact mechanism on larger pools with many more applications using microservices with sidecars. Increase the business criticality of the service being targeted. For now, it's pure infrastructure stuff, but we want to use business services. And we want, of course, to use it for new projects, especially when integrating the client-side load balancing is not possible or easy. From our API point of view, we want something as agnostic as possible, meaning that we start changing our client-side load balancing API, and just by adding a with Connect, you're going to use Connect even on those client-side load balancing APIs. So the benefit would be for this application to use TLS and to use intentions from scratch. And we will start, of course, having very similar API also helps you a lot to do some kind of A/B testing, especially when it's business critical. And finally, all of this seems like we are moving very slowly. We are having a service mesh with sidecar for more than 6 months, but we are moving very slowly. Why? Simply because at large scale, systems such as service mesh are very expensive. They require lots of preparation on existing infrastructure. For instance, Consul Connect doubles the number of services we have. So starting from 4,000, you go to 8,000. It has a significant impact on Consul performance. So we work quite a lot with HashiCorp to improve the performance in all of those cases. And so you have to really take care on a large infrastructure when introducing those sidecar service mesh stuff. And of course, you don't have to, you have to think that all of this includes the complexity of your system. Yes, you've got features. Yeah, you've got standardizations. You've got HTTP2, you've got TLS and so on. But still, when something goes bad, that's one more layer to handle. So thank you very much. This is the end of this presentation. We are doing some blogs. You can have a look, and we are blogging a lot on what we are doing on Consul, our incident, and the various patch we are working with. So thank you very much. I've been a bit too long, and Peter.
Yeah, you're totally fine. I really appreciate your time. We'll open it up for questions real quick just to see if we have any come in. So feel free to enter them into the chat. While we're waiting for that, I did want to ask you, Pierre. So obviously you've been doing this for a long time. What do you kind of wish that you had known from the start that might have helped you along this journey? Like, what kind of roadblock did you hit that you felt like would have been good to know when you were starting this whole transition to service mesh?
Probably the biggest issue we had was doing too many things in-house, which is good for being free of changing of vendors and stuff like that, but still it's a huge amount of work. Not implementing in the first place TLS was probably a mistake, but it was in the era it was too expensive to implement by yourself. And all the big issue with that is you've got lots of tutorials of Hello World tutorials, but the problem with Service Mesh is doing it on a legacy infrastructure, because legacy gives you money and business. So there's nothing really specific in the history that we could have done things much more differently. But I'm really a big fan of Consul Connect because it's a very simple tool to do that. You've got lots of other implementation. The good thing about it is you can choose to use Sidecar or not. You can, and the feature set is small compared to lots of other systems, and simplicity is very important for us because it's really hard at this scale to avoid, I don't know, being too complex.
Perfect, thank you. Okay. Last question I'll say is like, what are you the most excited for with your Service Mesh project? Like, what's the next big thing that you are really excited to see kind of come to the reality?
For us, we are kind of weird consumers. Like we are mostly interested with TLS and intentions. What I would be very excited with would be to generate a graph of calls in our data center with intentions, meaning that what is very complex is very large scale systems is defining a path, the path of a failure. Whenever a small microservice is down, you would like to see which service will be impacted. And having intentions allows you, if you are very strict about that, you can build a graph of dependency of services. So you can have an idea about what is going to be the impact of failure. So that's why I am very interested architecture on the architecture side.
Awesome. Thank you so much. Okay. I want to be conscious of your time because I know it's a little bit late where you are. So Pierre, thank you so much. Really appreciate you taking the time to talk to us today. Folks, if you have any additional questions for Pierre, we can always drop them to him as outside the chat and reply back with any answers. At this point, I'm going to transition to the next session.